nature, right? Let's look at how nature would have done it, right? So suppose, because the STPs, we've been shitting for ages, right? How does nature does this? So how nature treats waste is using a concept called anaerobic digestion, right? So that's how it works. And there are many flavors of digestion, but I'll just talk about that. So this, let me give you an example of how if you keep a sugar outside, the ant comes and you just put throw away some sugar, ant comes and take the sugar, right? How does ant know that sugar is there, right? And so it's a similar, this is how the nature design. So it's got, I'm not going deep. There are 5 stages in an anaerobic digestion system. So when you put let's put a box of rotten tomato in your in a flush down, or you keep a tomato in a refrigerator, right? So what happens is the 4 5 stages happen. There is first stage called hydrolysis. So you keep a tomato in a fridge, keep for some 1 month, 2 months. This is what exactly happens. So one set of bacteria called hydrolysis bacteria, these guys come and convert it, they disintegrate the tomato into, he knows that tomato is laying for the last 3 4 months. He's not going to, no one is using it. Let's demolish it. So he converts it into glucose, right? So one set of bacteria, right? And then he moves away. This is how the nature works. It's so beautiful, right? It's how we breathe, etc. Then the second set of bacteria comes, converts this glucose into alcohol, right? In fact, a lot of people are doing research on this. Can we stop at this stage? Can we just convert straight, get into alcohol, right? So, but they're not able to crack the nature's code. So it doesn't stop at alcohol, right? So third stage, another set of bacteria moves alcohol to ammonia hydrogen. So another set of okay. And the fourth set of bacteria, the methanogenous bacteria, comes and converts into CO2, methane. It converts into 4 or 5 stages, and a lot of water. So what you get is clear water out and few gases, and very little sludge, because sludge is eaten away with the anaerobic bacteria. Because this is how it works. So if you go to septic tank, this is how it works. If you go to cow stomach, that's how it works. Unlike a human stomach, is a very enzyme based. Cow stomach, this is how it breaks down. So 4 stages, 4 sets of bacteria naturally formed, comes and breaks it. You can always enhance the bacteria, you can do some catalysis, but fundamentally this is how it works. So when you move this into a tank, this is how the typical tank is, a typically 2-stage system, like you saw in an aerobic system. So all the fecal matter flushed down, it comes in a tank. It's nothing like a septic tank. It comes in here. Then it goes to multiple small partitions, multiple baffles. You have baffles. You go up, go down, up and down, go down. And any anaerobic technology, more or less, is a similar concept. So, like I said, in aerobic, you have blowing air through fecal matter, and this for them, this is the way it works. So it goes in. There's a scummed air formed, and it gets treated. There's a bacteria disintegrates. Like I said, the 4 sets of bacteria comes in. It disintegrates everything, and clear water comes out, and you can have multiple boxes like this. So you have better purity, put more boxes. So same concept, you put more, and you can add more techniques to it. You can improve it. There's a lot of science going behind it, though it looks so simple. And you get clear water out, and then you treat it further. So again, I'm going only the basic building blocks. So the baffle going up and down. If you look at phytorate or DRDO, biodigester, EcoSTP, they're all similar. More or less similar concept.
So this is add at the business level a question that you have to ask anybody who you're talking to. Let's say you've got 100,000 liters of water discharge, and that you want to plan for a new building or an existing building. When you go to any of these people, they will come and say, okay, 100,000. You have to ask them what is the size of your tank, and typically they will take 1:2.5, 1:3, and if they're really good, they will say 1:2. That is, if I have 1 lakh liters, they will take, say, 2 lakh liters as the total sizing of these tanks that he is putting up here. Now, the sequence will be more or less the same. Depending upon what the technology is, they will decide what the sizing of each of these things will be. That last tank is not yet come there. The settlement tank will be the one that is critical for him, and the aerator tank, the third tank. Now, what happens to you, therefore, is if he says 1 lakh liter is 2 lakh liters for you, 2 lakh liters into 15, 30 lakhs is your money. Now, if he says, no, I can manage with 1.5 lakh liters instead of 2 lakh liters, then you know your civil works cost is going to fall as much. And there are some of them where they go up to 1:2.5 or 1:3, and you're dead. I have said no to such people, because I have said, look, if you can't come up with something where that autonomy or the turnaround time for the water is not good, I mean, it's not fast enough, I don't need your technology, I keep telling them. So that is the difference. See, this end, what Tarun talked about, at the other end of the spectrum is the DWATs, like without energy at all, zero energy. The other end is MBR. Now the other one's SBR, MBBR. Let's not discuss it now. I'm saying to you that you have to understand how much there will be as a trade-off between civil works cost and the equipment cost. Please keep this in mind, because that is where you lose money.
Absolutely, yeah,
absolutely.
You're on the spot. Right. Yeah. So these tanks need to hold, like Dr. Hari said, need to hold a lot of water, right? So there's no blower here. There's no moving parts here. It's all completely natural. So the bacteria needs time to slowly. This is anaerobic bacteria, not aerobic. Anaerobic bacteria needs time to break it down and convert, because he's doing a proper treatment. He's not just he's breaking down the sludge and taking the oxygen out. So it's a lot of hard work this bacteria is doing. So sludge is very less. There's not less sludge produced, unlike in aerobic bacteria. So he's doing a proper natural job. Like I said, 4 sets of bacteria, its own coming. He has to inform the other bacteria to do it. So it takes time. So you need a larger tanks. So typically 72 hours to 80 hours, the water has to be, you have to hold. So if it's a 10 KLD tank, you need to have a 30, 40 KLD tank, larger, big tanks, right? So which means more civil work. So typically costs around 50 to 60,000 rupees per KLD, civil cost for this. One-time cost, but that's to build this big tanks. Top area, depending on the technology, can be completely reused. Some technology you can't reuse, DVATs only you can reuse, some technology you can reuse, but that I'll come to that. But fundamentally, this is how the tech works. So you go through multiple changes and large tanks, and this one-time capex heavy investment. You take this plug, put all the pipes in, multiple tanks. Design is very complex. You have to get a very good designer to do this. It execute very well. All these pipes should be the same level. There's a lot of intrication, but a lot of science goes into this. It's not, though it's so simple. Then once you've done it well, it just runs. It runs. So no hardly any maintenance. Only once in 2 years you have to remove the sludge from here, or 3 years. Sludge, you call a septic tank guy and remove the sludge. Generally, no other it's like a septic tank. The septic tank does nothing to. It's an advanced septic tank created by nature. Now this clear water that comes out needs tertiary treatment system. Remember, we went to the activated charcoal filter and pressure sand filter, right? Now, nature never had this activated charcoal filter. Nature never had this pressure sand filter those days. So how do you make it better? So that's why you use something called a wetland. So I'll come to this. So this tank, when you construct, this is how it looks like, right? It's a large tank. It's a civil work in progress. So multiple pipes, dig the thing. You put all the pipes in. Water flows from one tank to another one through pipes. Any technology, any anaerobic technology, take phytorade or DVATs or EcoSTP or DRDO, DRDO biodigester, more or less similar. There'll be combination of change, but there'll be and some of them put bacteria add-on, some don't put bacteria. Like DRDO puts bacteria as an add-on, which they say the source from Antarctica. So some don't put bacteria. So different combination, but fundamentally is all heavy civil work one time, right? And cost 50,000 rupees to 60,000 rupees per KLD. Once done, it'll be like this, right? So in top area can be fully utilized in the case of EcoSTP. So this one apartment, you come in, this is the whole thing, and this last stage plant filter comes in. So it's nicely integrated to a system. Money spent one time, and then remove the sludge once in 2 years. Disinfection you have to do, either chlorination, if you want to use for flushing, you should use chlorination, ozonization, or UV. That's immaterial. In this case also they use that for flushing, for car wash. So that's anyway you have to do it. Any tech you that needs power, that needs moving parts, small moving parts, depending on the technology. This is another system where we've done this. OCC is all manholes. So the children playground. Below this is an STP, goes naturally along with the system, and then you can top area can be reused. So if you can reuse the top area, this is very good, but it needs a lot of space. So this is how you save the space, because it needs double the space than a normal STP, really double the space, right? So, and double the civil cost primarily. So getting space. So how do you integrate it is a issue. That's why you need a good designer to make sure that it happens well. Now the third stage, the second stage, how do you replace activated charcoal filter and pressure sand filter using a natural technology? That's what we use this plants. So the different types of plants, and you can have a mix of charcoal filter and the plants depending on the need, how much purity you want, right? So it depends on how much purity you want, what's your goal, what's the cost, how much space you have. If you have more space, you can put more plants, and this is very natural. It's a good, again, it's a very good old system. You put plants, water flows through the roots. There's no mud here. It's only pebbles and rocks. It cleans the water and comes out. So this guy does the plants does oxygenation. It takes the air, it to the roots, rhizomes. It supplies oxygen to the water. It oxygenates the water. It cleans. It removes all the the pollutants, the TSS, all stuff, even heavy metals is removed. It's pretty neat system, very good old system. The plants needs trimming, that's all it needs. And this is how physically it look like. This is from Suhail's place. So there's no space, so we tucked in one corner. So these plants, so the typical Kana, Colocasia, and Papyrus, 3 types of plants are used. Water flows through the roots of these plants, and then you get the clear water out, and then you do disinfection on top of it. That's how the thing. So any tech you take, this how the typically the two items. Item number 1 is a tanks, and then the second is the plants. So the benefits are you don't need any minimal load, right? But the normal STPs needs 30% minimal load. Like I said, example of an office where with the COVID time, no one is there, STP doesn't work. So no minimal load, no smell because completely sealed. Operators not required. ROI is less than 2 years because it takes 2 years to make the recover the money because ROI compared to an conventional STP system. So this will cost 15 to 20% more. So that extra money, 50 to 20% more, you recover, right? But and that's how it works. No power, of course, it's approved by Pollution Control Board. No operators. It needs more space. I'll come to the advantage and disadvantage both. Now, go a little deeper to how they compare these two, right? Aerobic versus, this is the crux, aerobic versus anaerobic. So this, the left side is my, that dog I have, is a Great Dane. It's a very nice dog. It needs food to be given. It's like aerobic bacteria. Nice, food has to be given in a platter, in a higher level, right? You cannot, you can't, if you put it down, you'll have a backbone issues and all. So it is, that's how the breed is. And then you have stray dogs, doesn't need anything. You just go and takes it, right? So anaerobic bacteria is like a stray dog. It just survives. This is a septic tank guy. You don't need air, nothing. It just works. You just get the job done. So the 2 types of, so what it means is to you as a developer is it works with just one toilet, no return activator sludge, no MLS. So typically in an STP operator use jargon like RAS, MLSS monitoring, those no oxygen, those headache is not there. It's all once done. It's just nature. Done well, that's important. Designed well, and the stray dog has to be designed well, stray dog has to be executed well. Then it just runs. No tender loving care required. Cost trend, this is how the cost trend looks like. Initial cost, the big savings comes over a long period, right? Not the short term. Because this is like a, anaerobic systems are like a civil structure, like a building you make. There's no moving parts. It's built forever, right? Or we say built to last. So savings comes in the long term. Initial costs are higher, 15 to 20% higher because of the civil cost involved, primarily. But civil again, cement, steel, labor, and sand. So we found customers in Lucknow and all doing at a very low cost, 20,000 to 25,000 rupees per KL they're able to manage. So if we can manage these 3 parameters, right? Cement, you get cement cheaper or labor cheaper or somehow, or labor you move when free labor you move to the STP work. So somehow you have to value engineer the civil construction, then you can possibly do this. But key thing is the savings is for the people who use it, because you heard the slide before, 13,350 per month or 350 rupees per month. Those headaches are not here with this. So lots of disadvantages. I'll just list it out, right? More space needed than MMBR and SBR. Those space can be recovered at least one time. I need to have space, right? So space, more space. 15-20% more capex. Capex is more. I said 50 to 60,000 rupees per KLD versus 40,000 is difference. Popularity is low. It's not very popular, right? It's not 99.9% use aerobic STPs, right? 99.9%. That's a big number. Low awareness among MEP PhD consultants. Very few MEP PhD consultants know about this. They all studied motors, filters, right? Many of the books they only teach aerobic STPs. The wastewater engineering book by Metcalf speaks only aerobic systems, not anaerobic. It's a thick book. This is a book everybody reads. So this is a book. This is a Bible in environment engineering. So is a lot of even very less information on this in anaerobic, how anaerobic system works. The research is going to aerobic. Research is going to better blower, better. Now you got blowers with less sound, or better diffusers with the. So a lot of work is going in that. So anaerobic is getting a pushback. And design and execution is a key because in aerobic systems, you can, if something doesn't work, you can just pull a motor, you can do something, and you can find someone to do it. Here, you can't rectify the damn thing. You put it in, it doesn't work, then you have to call the guy to fix it. So design and execution is key, as you can. It's not easy to rectify. You have to do it right first time. You can't retrofit something. You can, but it's very, very difficult, right? You need space to retrofit. So you have to do it initially when the building planning itself, to plan for it. Later on, usually what we do is we keep the STP for the last, and then you wake up and say, yeah, let me put STP. Then there's no space, so it will retrofit. There are only few vendors. We have I listed DVATS, NERI, Phytorate, DRDO, Biologic, EcoSTP, only 4 or 5 vendors, not hundreds of vendors in the market. DVATS again, DVATS doesn't do themselves. They have multiple licensees. NERI has got multiple licensees, and they're not licensee not good as a parent technology. So they also learn a little bit. DRDO again doesn't sell directly. So a lot of licensees, but very few core technology in the market.